Hello everyone. So in today's video, I'm going to review about the previous video and also teach about completing the square and also about complex fractions. If we have the expression x squared plus bx plus c, we need to find uh, p plus q is equals to b, but p times q must be equals to c. Okay, and if we have a coefficient of x squared which is greater than 1, let's say ax squared plus bx plus c, then what we do is times the constant by a, right? X squared plus bx plus ac, and then we factorize it in the form x plus p, and let's say x plus p and x plus q, right? But because we had an a in our expert coefficient, so we must divide a in both sides. If they divide, then it will be a whole number. If not, then put, let's say, p over a becomes a whole number, let's say plus k, and then q over a is not a whole number, it's fraction, so we have ax plus q. Okay, and we also learn about factorization, the basic factorization. So if you have x squared plus x over 2x plus x cubed, then we find the greatest common factor on the numerator and denominator. So x times x plus 1 divided by x times 2 plus x squared. Cancel these, we have x plus 1 over 2 plus x squared. Another example, if we had a squared b plus b squared a all over a b plus a squared b squared. Okay, then to simplify this, find the greatest common factor. The numerator is a and b, so a times b will be a plus b. Okay, all over a times b 1 plus a b. Cancel these, we have a plus b all over 1 plus ab. Okay, and just a reminder that if you have an expression p plus q all over some number k, this is simply p over k plus q over k. All right, okay, now that's the review. What if we had polynomial which is a quadratic, which we can't really factorize it, or the question asks for us to make it in the form of x plus h squared minus k, or something like that. So what we do is, that's called method of completing a square. How to complete a square? Let's say we had a quadratic with a coefficient of 1 as the square, plus bx plus c. So we need to add by b over 2 squared. Okay, once we add by b over 2 squared, then we must minus by b over 2 squared also. So the question still the same with the previous, and add by our c. Okay, so if we think logically, if we had x plus b over 2 squared, then using the formula we have x squared plus 2 times b over 2 times x times plus by b squared over 4. Well, this will become x squared plus bx plus b squared over 4. Well, this is technically the same as this expression here. So we can make this into this expression, x plus b over 2 squared minus by b over 2 squared plus c. We're going to evaluate this, then we got the expression x plus b over 2 minus by our k. Okay, so let us have an example. Let's say we have x squared plus 3x plus 1. We can't really factorize this regularly. So if we want to complete the square, we need to divide the coefficient of the degree 1x by 2 and then square it. Okay, and we have to minus by 3 over 2. We square it and add by 1. Since this is this expression here, so we can do this 3 over 2 squared minus 3 over 2 squared plus 1, x plus 3 over 2 squared minus 9 over 4 and add by 1. This will become x plus 3 over 2 squared minus by 4 times 1, 4 over 4, and add by negative 9 would be negative 5 over 4. Okay, so this will be the vertex form, or when we complete the square. So what if there was a coefficient higher than 1? So what if 2x squared plus x plus 1? Okay, first we need to factor out the 2. 2x squared. If we factor out the 2, that means let us leave out the 1. So we have 1 over 2x. This will be the same as this one, right? If you distribute the 2, it will be this expression. Now we do the complete the square method. Plus 1 over 2 x plus by 1 over 1 over 2, no, 1 over 2 over 2 squared, and minus by 1 over 2 over 2 squared, and add by 1. Okay, 2 times x squared, no, so x squared plus 1 half x plus 1 over 2 over 2, which is 1 over 4. Okay, 1 over 4 squared, so x squared, so x plus 1 over 4, this thing squared, minus by 1 over 4. Okay, it will be 1 over 16 because you squared it, so 1 over 4 squared, and add by 1. We have x plus 1 over 4 squared minus by 1 over 16 times by 2 plus 1. We distribute the 2, it becomes x plus 1 over 4 squared minus 1 over 8, 2 times 1 over 16 plus 1. This will become 2 times x plus 1 over 4 squared. 8 times 1, which is 8, and then minus 1 would be negative 7, positive 7. So positive 7 over 8. So this is the vertex form, or the factorized using the completing the square method. Okay. Now, on the next, let's review more about coupling the square. What if we had negative 2x squared minus 5x plus 1, right? So, again, factor out the negative 2, x squared minus, or positive now, positive 5 over 2, x plus 1. Okay, now we complete the square, which is 1 over 5 over 4 squared, and minus by 5 over 4 squared, and then we add by 1. So negative 2 times um, x plus 5 over 4 squared, and then we multiply negative 2. This becomes positive 2 times 5 over 4 squared, and add by 1. Negative 2 times x plus 5 over 4 squared, add by 2 times 25 over 16, add by 1. 25 over 8, and 8 by, add by 1. Negative 2 times x plus 5 over 4 squared. Now, this will become 333. 8 times 1, 8 over 8, which is 30, yeah, 3. 3 over 8, and negative 2 times x plus 5 over 4 squared. Okay. Now, how about if we had rationals, rational expressions, yeah, another review. So, what is a rational expression? When the numerator and denominator are polynomials, aka this one, if you guys remember, a n x to the n plus a n minus 1, a to the n minus 1, and add a1 x to the x plus a naught. Okay, so if we had a rational expression like 5x plus 6 over x plus 3, remember, we can factorize this. So x plus 3 and x plus 2, find the number which adds up to 5 and multiply to equals to 6 over x plus 3. X plus 3. We cancel this, we have x plus 2. This is called a rational expression. Now, what if it was like this? 1 over a plus b over a minus b. Okay, so to do this, remember what's the definition of division? If we have 1 a divided by b, this is the same operation. A divided by b equals to a divided b. So it's the same thing, a times, right, a times 1 over b. Using that, we can conclude that 1 over a plus b divided by a minus b is the same thing as 1 over a plus b times 1 over a minus b. Well, we multiply them directly. Remember that this is a perfect square. I mean that the difference of square. So 1 over a squared minus b squared. That's the result. What if we had these? So a plus b over a minus b over a plus b. What do we do? Again, this is the same thing as a plus b divided by a minus b over a plus b. 1 over a plus b times uh, the this rational is switched. So a plus b over a minus b. This cancels, which leaves us with 1 over a minus b. Another example, let's say we have 1 over a squared plus b over 2 over a plus b and add by 1 over b. Okay, to do this we must of course simplify this first. So 1 over a squared plus b, so let's directly do it. So this will become a plus b over 2, and then we add by 1 over b. Since we cannot cancel anything, we multiply it directly. So 2a squared plus 2b, this is a plus b, and then plus 1 over b. Okay, now you find the lowest common multiple, which will be or we times this by b, cross multiply, plus times this by 1 times 2a squared plus 2b, and all divided by, okay, b times a plus b, and 2a squared plus 2b times 1, all divided by b times 2a squared plus 2b. This would equal to ab plus b squared, ab plus b squared plus 2a squared plus 2b all over 2a cubed, 2a squared b plus 2b squared. Okay, how about, let's say we're trying to okay, remember that if we had a rational at the bottom or the denominator, then 1 over square root of a, we need to times by root a on the top and the bottom, which leaves us with square root of a over a. So we have x squared plus 6x plus 3 over square root of x plus 1 times square root of x plus 1 square root of x plus 1. This will become x squared plus x squared root x plus 1 plus by 6x root x plus 1, and then plus 3 times root x plus 1 all over x plus 1. Okay, and what if we have this expression a plus b over c plus root d? Well, to do this we need to multiply by the conjugate to remove the rational at the bottom. Why? Because remember that if we have a minus b times a plus b, it will simply become a squared minus b squared, which will remove radical. So we have a plus b times c minus root d all over c squared minus root d squared, which will have a c minus cl, a root d plus bc minus b root d all over c minus d. Okay? Okay. Now, another example. An exam 2 plus 3, 2 plus root 2 over 3 minus root 2. Well, to rationalize this, we have 3 plus root 2 and then 3 plus root 2 times the conjugate, which the conjugate of the denominator will be addition. So this will become 2, 2 times 3, which is 6, 6 plus 2 root 2 plus 3 root 2 plus root 2 times root 2, which is 2, all over 9, 3 squared minus square root of 2 squared, which is minus 4, minus 2. We have 6 plus 2, which is 8 plus 5 root 2 over 7. Okay, that's rationalizing. Well, I think that's it for this video. So in this video, I've reviewed the previous video and also some rationalizing, and we'll learn about completing the square and also complex fractions. See you on the next video.